Hi Math 3 students! Today we are going to be working on graphing piecewise functions. So you have graphed lines before, you've graphed quadratics before. And so what we're going to do here is, starting off, we're only doing lines, so don't stress out too much. So what is a piecewise? A piecewise function is a function that only holds true under a certain domain, okay? So let's look at this on a graph, okay? This is the line 2x plus 5, okay? Now, if we look at our worksheet, they told us that 2x plus 5 is only going to be good on the domain for -3 to 0, okay? So the way this is going to look when we graph it is we only want to graph this function from -3 to 0. So this is what it's going to look like when we graph it, okay? Now, the piecewise functions that have like two distinct endpoints, when they're linear, they're super easy to graph. All you need to do is plug these two endpoints in and graph them, okay? So if we've got -3, let's plug that into this function and get our output. So we're going to do 2 times -3 plus 5, okay? That gives me -6 plus 5, that gives me a -1. So my first point for this guy is going to be -3, comma, -1, because I put in a -3, that was my x value, I got out a -1. Then we're going to go ahead and put in our other endpoint of 0. So we're going to do 2 times 0 plus 5, which gives us 0 plus 5, which is 5. So our coordinate would be 0, comma, 5. Okay, so now you're just going to go ahead and plot those two endpoints. Now, when you plot them, pay attention to if they're supposed to be open or closed, right? The -3, that has the equal sign, right? So the function is good at -3, so we would do a closed circle. And then at 0, it's supposed to be open. So we're going to go ahead and go to -3, -1, and do a closed circle there. And then I'm going to go plot my 0, 5, and that needs an open circle there. All right. Now, let's go ahead and try graphing the next portion of this function. We'll plug in a 0 and plug in a 6 to this function now. So we're going to plug a 0 in, so we do negative times 0, or it's like -1 times 0. Plus 4 is going to just give us a 4 out, so 0, comma 4 is our first point. And then we're going to plug a 6 in, so we do -6 plus 4, which gives us a -2. So we end up with 6, comma, -2. Don't forget, these guys are your x values, right? That's what you're plugging into here. And then your y value is what you get out when you plug it in. Now, both of these guys are going to be open circles. So, let's see, we've got 0, 4, and we have to do an open circle there. And then we've got 6, -2, and that is also an open circle. Oh, and I forgot, on this first one, we got to go ahead, it's a line, right? So we got to connect the line there and connect the line there. Sorry, I forgot to do that with the first one. Now, we're able to just do the endpoints and connect the line because these are lines. If it was a quadratic, something that looked like this, it'd be a little bit more complicated to graph. But with lines, they're pretty straightforward. All right, so now let's take a look here at number 3, okay? These ones are different because they don't have two distinct endpoints, okay? So, like if we go to graph this, what is it? -6 minus 6, x less than -1. Oh, I forgot it already. -3x minus 6. Okay, so -3x minus 6, all right? And we're graphing this for functions. We have x values, and I think it was less than, I don't know if it was less than or equal to. It's okay, it doesn't matter too much with graphing. On Desmos. All right. So if you notice this one, instead of having two distinct endpoints, it ends right there with an x value of -1, but it goes off into infinity. Okay, so we don't have two distinct endpoints to plug in. All right. But what we can do is just plug in another point that's close by it so that we have 2 points to connect the line. So you're still going to want to plug in your endpoint. So let's go plug in -1. So we're going to do -3 times -1 minus 6. That gives me 3 minus 6, which is -3. So my coordinate would be -1, comma, -3. Now, for picking another point to plug in, it doesn't, like, honestly, I recommend just doing one close by this, okay? So if I've got -1, how about let's plug in a -2, okay? So we're going to do -3. Oh, actually, hold on. Let me explain why I picked -2. So we've got our point here of -1, -3. And it's going to be open because there's no equal sign there. So let's go plot that. We've got -1, -3, an open circle. Okay. Now this function is good for everything over here, right? Because its x value is less than -1. So when we pick another point to plug in, we want to pick another point over here. Do not pick a point over here because that's not in its domain. Sorry, I should have specified why I picked -2 instead of 0. So that's why we picked -2 instead of 0. So -2 is going to be on the domain, right? And it's right by where we started. So it's a good number to plug in. Now, let's say you plug a number in and you get a weird decimal out. Just plug another one in, right? Like you could plug in -2. If that doesn't work, plug in -3. If that doesn't work, plug in -4. Hopefully, if at some point one of them is going to give you a whole number. All right. All right. So we have to go plug in a -2. So we're going to do -3, -2, minus 6. Also, this gives us a positive 6, right? And we got -6. So we get a 0 out. So our coordinate is -2 and 0. So we're going to go ahead and plot that, -2, comma 0. Now, remember, this line goes off into infinity. So when we draw this, we're not going to just connect those. We have to make it go off to infinity. All right. Now let's go ahead and do the other portion of this one. So we have 5 as our starting point of this domain. So, of course, let's go plug a 5 in. We've got -2 times 5. Plus 8. That gives us a -10. So -10 plus 8 gives us a -2. So our coordinate would be 5, -2. We can go plot that, and it's going to be an open circle. Now, for our next point, remember, this function is only good for x values greater than 5. So we're only looking at stuff over on this side. Do not plug in anything here. Don't plug in anything here, right? We only want to use x values that are bigger than 5. So a good number to plug in, why don't we try 6? So we're going to do -2 times 6 plus 8. So that gives us a -12 plus 8, which is -4. So our coordinate would be our input of 6 and our output of -4. All right, and again, when we have these ones that go off into infinity, make sure you specify that it's going off to infinity. And I did not plot that right. I plotted it at -5. 6, -4. Now, if you are someone that is able to just count the slope from a point, you are more than welcome to do that. However, I find that a lot of kids get confused on like which direction to go, if you go up, down, left, right. So if you're able to just like start at this point and be like, okay, I know that it has a slope of, what is this one, -3, so I can go up 3, 1, 2, 3, and over 1. That's perfectly fine. However, I find a lot of kids struggle with that because what they'll do is they'll, give it a positive slope, or they'll put it in the wrong direction or something like that. So I think it's a lot easier to plug in, a point right next to it. But if you're really good at plotting the, plotting slope, you can go ahead and do it that way. All right, let's go ahead and try another one. So now, this guy has two distinct endpoints. All right, so we're just going to go ahead and plug those endpoints in. So we've got -4, so 3 times -4 plus 6. That gives us what, -12, so we get -6. So we've got -4, -6 is one of our points. And that's going to be an open circle because it's not equal to. And then we're going to plug in a -1. We get a 3 out because it's -3 plus 6, which is +3. So we've got -1, comma 3. Again, that's open. So we can go ahead and plot that. -4, -6. Open circle. And then -1, 3, open circle. And then just connect those. All right. Now, again, we're going to go get our two endpoints here for this guy. And this guy is also just completely open. So we're going to plug in a -1, -2 times -1 plus 2. So we get 2 plus 2, which is 4. So we've got -1, 4. And then we've got -2 times 3 plus 2. So we get -6 plus 2, which is going to be -4. So we've got 3, comma, -4. So now we go plot these both with open circles, -1, comma 4. And, oop, that's not -1. -1, comma 4. There we go. And let's see, 3, -4. Like that. Connect them. All right. All right, let's do one more. So we've got another one that goes off to infinity, okay? And you're probably looking at this and you're like, what the heck, Miss Slat? How are we supposed to plug into this function for our endpoint, right? Well, this is just a constant function, so no matter what you put in, you are getting a 5 out, okay? So if I put in a 1, I'm getting a 5 out. So we can go ahead and plot that. It's going to be an open circle there. So we've got 1, 5, open circle. Now for our other point, this guy is good for x values less than 1. So we go down here, okay, and we can plug in any of these x values that are less than 1. Well, can't really plug them in, right? We know our output's going to be 5. So we could just say, okay, let's plug in 0. If we do 0, our output is 5, right? So you go to 0, output of 5. It's going to look like that, okay? So any constant function is going to be flat like that. All right, and then we've got 4, so let's do 4 plus 3, and we get 7. So we've got 4, comma 7, and then 4, 7, that's also open. And remember, this is good for x values greater than 4, so make sure you plug in something that is greater than 4, okay? So how about let's plug in a 5. So we would do 5 plus 3 gives me an 8, right? So I would do 5, comma 8, and just connect my dots and get my line.